Hi, I'm Matt Mason. Welcome to my ICRA workshop talk. I'm going to talk about to grasp or not to grasp. Really what this is I've been thinking, it's some recent thoughts about some familiar ideas in manipulation. We're going to look at some examples where a grasp is a good idea, some examples where it's a bad idea, and then some examples where I think the right thing is just not to think about it at all. It's sort of irrelevant. It may be happening, but it's not really part of the plan, tangential or. So here's a good example. The classic blocks world task. Put block A on block B. And it's obvious here the way to do this is to grasp a block. But really, when people are looking at this, thinking about it, it's an iconic grasp, right? The hand comes down, makes contact, control transfers from the ground to the hand, and then the hand can move it where it wants. Okay, it's a very simple thing. And so now it's not always a good idea. And here's an example where it's not a good idea. If you want to invert that block, the hand's going to intersect the table. So in that case, you don't want to grasp. There are other options. Okay, well, why not push down on this corner and rotate it? Or maybe push on that corner, or maybe some of each, and you can rotate it over into this position. So that's an example where grasping is not good. Here's an example where it is good. And I have to tell you, I have a conflict of interest here. This was done by Berkshire Gray, where I work. But you can see it seems to be very straightforward, and it's certainly very fast and very effective, and lots and lots of different things it can do. It's not as straightforward as it looks. There's actually a lot going on that you know, behind that you can't really see. But what's the value of this? Why do we want to grasp things? Well, in e-commerce, order fulfillment or warehouse or parcel sorting, there's lots of cases where actually just being able to pick something up turns out to be very valuable. Like if you're just moving things from one bin to another, picking up is a big part of the problem. So let's look at this example. This one literally arrived on my doorstep, and this is a case where it looks like I should grasp it. I can't get it across the lip of the garage. And so just pick it up. What's the big deal? Well, the big deal is I didn't want to die, okay? And in the age of COVID, something arrives at your doorstep. You don't know if there's COVID on it or not. So here's what I did. Kind of like that block rolling thing. That works. So there's a case where grasping was a bad idea. Now here's an example that I know probably a lot of you have thought about. Some of you might have even implemented it on a robot. So let's look at it just slightly more detail. You know, to pick that up, he's sliding it to the edge so that he gets access to the bottom face. Now, even then, he doesn't do a simple iconic grasp. It's a little more complicated, right? He tips it up to get better exposure of the bottom face, and then he grasps it, and he can do some in-hand manipulation. So that's a nice example. Let's look at a little more of that kind of thing. So this is more Othello. Here, he's flipping the pieces over, and you know, when I first watched this, I looked at it and I asked myself, is he grasping it or not? I'm not exactly sure. And which then raises the question, what's the definition of a grasp? Andrew Ng said, oh, it's a grasp if the hand goes up and then if the object follows it, and if it stays up in the air for like 5 seconds or so, then that means it was a grasp. And some people want to define a grasp in terms of forced closure. Either way, if you look at that carefully, it's hard to say. It looked to me like it might have sort of been in the air for a second, not enough to satisfy Andrew Ng. And maybe it gets forced closure, but you know, those are the wrong questions. That's the real point here, is that whether it's a grasp or not, it wasn't part of the plan, okay? And so it's really, I think, an emergent phenomenon. Here's some more of similar operations. So is he grasping it? Is he not? I don't know. I don't think it matters. But there is another perspective here, which is you could say, I'm going to treat the board just like it's another finger, and then I'm going to say it's whole arm manipulation or whole world manipulation, and I'm doing something like in-hand manipulation, but with the whole world. Sure, that's a reasonable way to look at it. Here's the last example of this kind I wanted to show you. Here it's placing, but you know, he can't place it and put it exactly into the right spot immediately. He has to miss by a little bit, get his finger out of the way, and then push it into the right spot. So there's some manipulation following the placement or as part of the placement operation. So now, when you watch these operations happening, you realize that, you know, every time a contact is made or broken, every time there's a change in contact modes, that defines a sequence of phases. Each phase is a constant contact mode. What's a contact mode? Well, if you have a contact at a point, you can say, well, it's fixed or rolling if there's no relative translation, or it's slipping or sliding if it is translating there. We're going to ignore the separating and penetrating modes. We don't need to worry about them here. And if you have several contacts, basically you need a list of those separate contacts mode to define the composite, you might say, contact mode. Now, one thing then, if we're going to work with contact modes, is we might want to be able to enumerate them efficiently. And this is some work done in my lab it was led by Eric Huang, and Xianyu Cheng also helped with it. So what you're looking at is that those purple vectors are velocity vectors. The yellow ones are for points that are in contact. And and all the contact modes form a lattice. So up here in the upper left, you see a lattice, and it was systematically walking through every contact mode, showing you the corresponding motion. Now here we have a much more complicated situation, and the number of contact modes is much greater. So great that the individual modes that are represented by yellow dots, they've all merged into one big line in the lattice here. So with that many contact modes, it certainly matters that you can enumerate them efficiently. So let's look at contact modes for these examples. Here's the pick and place example. I was prepared to notate sliding as well as fixed / rolling, but actually none of my examples have sliding, so we can just forget all about that. So here's the iconic grasp. Actually, it works better if you, instead of showing it, you know, moving in space, if you make it as a function of time. So at rest, you have the 2 contacts with the ground. When you're carrying it, you have 4 contacts with the gripper, and in between, when you're doing the iconic grasp, just instantaneously, you have 6 contacts. Likewise for the iconic place, and then we're back to rest. Now, I had some ideas about how to do a more elaborate chart of that kind. I was going to unwrap the surface of each body and then have lines connecting all the contact points and color them depending on whether they're fixed or sliding, and then, you know, and then put them on a timeline, but that wasn't working. And so this is a more abstract graph, and what we've got is just, you know, still time from left to right, and we've got a line here for each body. That's the gripper, here's the object, and here's the ground. And so the pick and place operation, you know, the ground's in contact with the object to begin when it's at rest. Here's the iconic instantaneous grasp or control transfers to the gripper. And then here's the iconic place. Somebody, Xianyu Cheng, actually said, hey, it looks like a gate diagram, which hadn't occurred to me, but it does. And but I guess I don't want to call it a gate diagram. Let's call it an Erdmann diagram. I didn't ask Erdmann if that would be okay, but maybe he'll think it's okay. Here's some of the other operations. Here's a regrasp. You pick it up, you put it down, you pick it up, you put it down. Here's pre-grasp manipulation, sliding the chip to the edge of the table. Here's in place manipulation. You never really pick it up. Shared control, shared grasping, you might say. Here's in hand manipulation, which looks just like pick and place. We don't have the details here, whether there's a lot of complicated stuff going on or maybe the gripper is just squeezing it. So what's the point of this? I feel like I get a little bit of perspective about what's a grasp about. If you're doing an iconic grasp, you know, the very first example, this doesn't add much. But for an awful lot of manipulation, what you see is that the grasp is more of an emergent phenomenon. And so maybe that helps. I promised to show you a little bit of the work that's going on in the manipulation lab. This is to explore, you know, can we control contact modes? So, and this thing is just showing off. It's just going through all the different contact modes that it can. And then here it's using control of contact modes to put a block up on a corner. Now, the way this works is that it's wrapping a force control loop around the velocity control that we get with the industrial robot. And there's about 1/10 of a second latency, so it's not as fast as we might like. Still, I think it's pretty impressive. This was work by Yifan Hu in the manipulation lab. And, you know, depending on the contact mode and the phase of the moon and so forth, you know, it works or it doesn't work. And a significant part of this project is to identify contact modes that are more robust, because a lot of them are extremely fragile, I'll say. So you can see it doing a lot of interesting things. This is somewhat akin to, you know, how to put block A on block B, I guess, and rotate it at the same time. I'm going to move ahead and show you one other system that we think will be able to do an even better job. So this is the direct drive hand. This is a project led by Anka Tabatia and a collaboration with Aaron Johnson at CMU's MECI department. So it's a direct drive hand. There's no transmission. And so what we think this gives us is transparency. And well, first off, it gives us compliance. That book is delicately balanced there, and yet the finger just swings out of the way if you're not deliberately forcing it to behave stiffly. It's also very, very quick. And so between the natural compliance and the quickness, and without having that other control loop in the way, we think we're going to have a very responsive, very compliant system that will be able to use to control contact modes very efficiently. So that's the direct drive gripper. So I think that's all I've got. Some thinking on my part, trying to figure out how to be less confused about grasping. I hope if it's had any effect on you, I hope it's been a reduction in confusion, not an increase. Here are a few references of the work I showed, and then there's a much, much longer list of references that I could be talking about. A lot of these ideas go back to earlier collaborations or work done by others, some of you in the workshop here, and some going way back in time. Really, I think Daniel Whitney's work on assembly was sort of, I think he led the way, and a lot of what we've done follows in his footsteps. Thanks to all my collaborators, and thanks to you for listening. And that's my talk. Bye-bye.